Jai Hind everyone. I am Anupam Kumar Saini, Assistant Professor, IT Department, AKGEC Ghaziabad. Today I am going to discuss about the NFA and DFA. So here we discuss some important question of DFA. So first we discuss about the what is the DFA. So DFA stands for Deterministic Finite Automata. In this, 5 tuples are used to describe the DFA: Q, sigma, Q naught, F and delta. Capital Q represents the number of states used in DFA, and sigma represents the finite set of input symbols that used to design a DFA, and Q naught represents the initial state, and F define the final state of DFA, and delta represent the transition of function, and transition of function is the function that describe about the current state, input symbol and next state. So this is current state, input symbol and next state. If you take this example of the finite automata, then this will be the initial state where start the machine, and this is the final state. Final state represented by double circle, and initial state represented by circle with arrow, and this is the labeling of any state. These are the inner states. So if we talk about the transition function, then we see that if we talk about the current state of when we are at Q1, then transition will be Q1 when input symbol is 1, means sigma is 1, and current state Q1, and input symbol 1. Then what will be the next state occur here? Q1. And when we talk about the transition function, Q1 when sigma is 0, then next state will be Q2. So this is the transition function, and this example so that the substring 10 occur in our machine. Means if talk about this substring, means element will be 10, 110, 010, 0100, means 10 as a substring should be there in the output we get. So this is the transition diagram. This is called transition diagram, and this is transition table. In transition table, we show about the present state, and this is the next state. Next state when input 0 and when input symbol 1. So this is the current state, means Q naught. Current state is Q naught. When the input symbol is 0, then next state is Q naught. When the input symbol 1, the next state is Q1. So this is next state when input 0 and 1. Similarly, when the current state is Q1, input symbol 0, then move to the Q2. So write here Q2. When input symbol 1, then next state will be Q1. And the final state Q2, when input symbol 0, then the next state is Q2, and when input symbol Q2, in current state Q2 and input symbol 1, then next state also Q2 for this group. So for this way we construct a transition table. Now we take some example to solve the DFA. So these are some practice questions. Question number 1 is, when the language L equal to W, W begins with 1 and end with 0, means string start with 1 and end with 0 over alphabet 0, 1. And next question is, the construct a finite automata that accepts set of strings where the number of zeros in every string is multiple of 3. And design, third question, design DFA for language W A comma B asterisk NB W mod 3 greater than 1. Fourth, design DFA for the language L 01I 1 to J. So I describe the question one by one. So question 1 is L equal to W, where W begin with 1 and end with 0. So when we take this example, so what string will accept by the finite automata? So start with 1 and end with 0. So this is the string will accept by the DFA. Start with 1, end with 0, in between any symbol occur. So start symbol and end symbol are fixed here. So what is the minimum string? This is the minimum string. So we design our DFA for this minimum string. So there will be initial state and input symbol is 1. Then we have to move next state Q1 with input symbol 1. Then the input symbol is 0. And its final state. So in this diagram, string 1 0 will accept. Now we take other input symbol 0 and 1 for all the states. So when the Q1 state, when we are at Q1 state, we move with input symbol 1 to Q1. Now check when the Q1, when input symbol 0, then what will be the next state? When we are at Q1, 0 not affect our machine, only say that start with 1 and end with 0. So the string cannot start from 0. The string cannot start from 0, means 0 then 0. That is not acceptable because the string will start with 1. So we have to move with 0 to any state from where no option to reach at final state. From where we cannot able to reach at final state, that state is known as the dead state. Means when start with 0, then move to the dead state, and at this state there is no option to reach at the final state, and after 0 any string occur 0 or 1 will not accept. Means 0 0 1 0 1, these string will not accept. So when we are at Q naught state, both input symbol are considered 1 and 0. Now move to the next state Q1. From the input symbol 0, we move to the next state Q2. Now check with the input symbol 1. So 1 start with 1 and end with 0. If there occur 1 at state Q1, then we take loop of 1. Means that not affect the given statement. Means string except with that is 1 1 0, start with 1 and end with 0. Now at Q1 state both input symbol are considered, and at Q naught both input symbol are considered. Now move to the state Q2. So when 0 occur, means if there is 0, then we can use as a self loop, because how in any times 0 occur at this state, means the input string end with 0. For example, 1 0 from the loop 0 1 0 0 0 mean end with 0. When 1 at state Q2 input symbol 1, then we cannot consider it as a loop, because when we consider it as a loop 1, then the string end with 1, that is not allowed. So we cannot use the loop of 1. So we check where to move with the input symbol 1 at Q2. Then we move at previous state 1 with input symbol 1, we move to the Q1. So if we consider this path, means string 1 start with 1 0, then 1, then 0, string will acceptable. So all the states are also use all the input symbol, means there are two input symbol 0 1, and each state represent where to move with the input symbol 0 and 1, because DFA said that all the input symbol will consider when construct the DFA. In NFA it can be neglected, but when we construct DFA, then we have to consider all the input symbol. So we take another example. Construct a finite automata that accepts set of string where the number of zeros in every string is multiple of 3 over alphabet 0 1. So multiple of 3, when 0 occur, will be a multiple of 3, means string accept here 0 will be considered as a multiple of any number. So 0, then multiple of 3 will be 3 6 9 for this way. So we consider, take here the for zeros only. So design a DFA, initial state Q0, input symbol 0, Q1, next state Q2 with 0. Now we check here the repetition of the multiplication of 3 and repetition will occur, means 3, 6, 9, means after 3 it will repeat again for the 3 input symbol. So we design a loop for that, so that these occurrence may consider. So when 0 at Q0 move to the next state Q1, and Q1 the 0 next move to the Q2, and as we see the this is acceptable, so this state will be the final state also, and we move with the help of 0. This state means if no any element except here, then the input symbol will be 0, means no string there. When 3 0 occur, 0 0 0, then we move to the final state, means 3 zeros are considered. When move further, 1 means Q0 to Q1 to Q2 to Q0, 0 0 0. Further Q0 to Q1, 0, Q1 to Q2, 0, Q2 to Q0, 0. So when 6 0, we move to the final state. This is only for the zeros, and 1 not affect at our given statement, so we consider it as a self loop. 1 1 1 means if we check the string 1 0 0 0 0 0 will accept here or not. So we see that how many zeros are there? 5. This is not the multiple of 3, so cannot reach at the final state. Check here. So first Q0 to Q0 with the input symbol 1. Next state 0 to Q1, 0 Q2, then 0 0 Q0, here 3 0 taken. Now 0 move to Q1, 0 Q2. So this is not our final state. This is not our final state, and we are consider the string 1 0 0 0 0 0. 1 0 0 0 0 means this string, and we cannot add the final state. When we add another 0, so it will we reach at final state, so this string will acceptable. So this is the complete DFA of a string where zeros are multiple of 3. Now take one another example. Design DFA for language WAB star where N, B, W mod 3. Here the different type of question that says occurrence of B. We here see the occurrence of B, and what are the condition given here? Mod 3 greater than 1 means when B occur in this B. If we take mod value of 3, when consider mod value of 3 for this B, when for this mod value will be 1, and when we take mod value, what will be the remainder? 0, 1 and 2, and say that consider only greater than 1. So what will be the mod that will acceptable our machine? Only 2, where mod value 2 for B will acceptable. So current state is Q0, next Q1, Q2, so input symbol B and B. So here accept the string where mod value is 2. Now here will be 2, 5, 8, 11, 14, where number of occurrence of B is 2, 5, 8, 11, 14 should be acceptable. So we have to design a loop for that B. So now check the for 5 B's, this is acceptable or not. 1, 2, 3, 4 and 5 at final state. There is no any condition for A, so we construct a loop for A and A. So this is DFA for NB W mod 3 greater than 1. Okay, thank you for today. I will discuss next question in next class.